friends, welcome back to my channel again, and today I will continue the topic of chopper where I left last day. And before that, I am requesting you to please subscribe my channel and click the bell icon. Now one of my friend and one of your visitor have requested me to give an answer about a question that what will happen if we don't use that inductor. Now see, in the circuit we are using a freewheeling diode and a load, and there we are using a switch. So while the switch is remain closed, while the switch is closed, the circuit will flow, the current will flow through that inductor, and the inductor will charge. And when after the switch gets disclosed, then the freewheeling diode will conduct and the inductor will discharge that time. So when switch is closed or the switch is on, the inductor is charging, and after the switch is remaining off, the inductor gets discharged. So the function of the inductor is to charge and discharge, and by that term we are getting that output wave. So if we don't use inductor, there will be the output what will be not necessarily needed. So that is why we need inductor. So the use of inductor to store while switch is on and discharge while the diode is on and switch is disconnected. Now today I will discuss about the types of the chopper. Now here you can see there is a two output wave. The first output is about the voltage output and the current output. So depending on the voltage and current output, if we plot inside a 4 quadrant, we will get different output waves. Somewhere we will get the output on the first quadrant, or somewhere we will get the output on the second quadrant, or sometime we will get the output at both the first and second quadrant, or both the first and fourth quadrant. So the output is depending, and depending on that output we have classified that chopper is mainly of 5 type. So depending on the chopper waveform, that is the chopper waveform, output waveform, the chopper is classified into 5 type. Here I am going to write the 5 types. The first type is called as type A. In type A, we will get the output at the first quadrant. So for the type A, the output will be at that zone, first quadrant. The second one is type B. And for type B, we will get the output at the second quadrant. Now type C. The third type is type C. For type C, we will get the output at both first and second quadrant. So both first and second. So for type C, we will get the output at both first and second at that time. Now type D. In type D, we will get the output at the first and fourth quadrant. So for here it is type D. And type E is the fifth type. It is type E. It is a combination of all. So we will get output at every type, every quadrant. So now I am discussing about the type A. Before that, again, see, there is 5 type. There are 5 type: type A, type B, type C, type D, and type E, and all have different characteristics because of the output we will get in the VI quadrant waveform in different quadrants. So now coming to the topic of type A. Type A is the first quadrant chopper, and the circuit that I have drawn previously, that is type A. And type A, we will get the output at the first quadrant. See, here I am using a thyristor with the input voltage parallel with the freewheeling diode and a inductor along with the load. The purpose of using freewheeling diode is after one cycle of that thyristor. Thyristor will be open and the freewheeling diode will contact, and the process will remain vice versa. Now the first step, the first operation when the thyristor is on. So here at the thyristor is on, the freewheeling diode, it is called freewheeling diode because it is continuously be forward bias and reverse bias. So at that time the freewheeling diode is reverse bias. So when it is on, it is reverse bias. The freewheeling diode is reverse bias. So it will not contact and the circuit current will flow through that path. So the process will be from V in to the thyristor, to inductor, to load, to again V in. Now when it is open or it is off, so it will not contact and the freewheeling diode now will be in forward bias condition. So it will contact. So the circuital operation will remain from this path. So the freewheeling diode is contacting and the inductor, previously the inductor get charged, now the inductor will be discharging. So the inductor will be discharging through the load and through the freewheeling diode. So the current will now pass through that process. That is why it is called a step down chopper, and the operational output waveform will look like that. So that is why it is called as quadrant 1, because the output we will get, because every time we will getting a positive output. Here we will getting positive output. For that again we are getting a positive output, and for that because current is passing throughout the positive direction. So every time we are getting a positive directional output. So everything will be in first quadrant, and that is why it is called as first quadrant chopper. I think you have understood that, and please subscribe my channel and I will keep continue this topic.